This program is brought to you by Stanford University. Please visit us at stanford.edu.
This presentation is delivered by the Stanford Center for Professional Development.
The speaker today is Werner Vogels from Amazon.com. He did his doctorate at the Free University in Amsterdam, was an academic at Cornell, and has been working at Amazon ever since. I brought some show and tell. This is the stuff we're talking about. It's part of the latest of the O'Reilly Press books. So there's now the missing manual for stuff. If you pull the camera over, you can get the cover. There we go. And then the other interesting thing, which I dearly love, and a few people agree with me, I think quite a few people, because you can't buy them, is the little Amazon Kindle, which is where you put the books that you need to carry around and read and don't want to put in your backpack. So this shows, I think, the technical innovation that Amazon.com, ostensibly a bookstore, is doing. In any case, the talk today is titled Ahead in the Cloud, the Power of Infrastructure as a Service, and we're looking forward to it. Thanks.
Thank you, Dennis. Actually, as of today, the Kindle is in stock. So go online. And no, I didn't bring it with me, but I've got one in my bag. It's got cash on you. Then we can do this deal. So, how many of you are Amazon customers? Or let me actually. Okay. So, which of you is not an Amazon customer? Yeah. Can I talk to you later? So this is kind of the challenge that I have. Yeah? You're all Amazon customers. Hopefully you love the experience of shopping on Amazon. And you do not want to think about the fact that if you put something in your shopping cart, it goes into a replicated DHT with a sloppy quorum mechanism and eventual consistency with versioning techniques that require reconciliation somewhere later. You don't want to think about that, do you? Let's hope it works. Well, this is indeed the technology that is underneath the shopping cart. You never noticed that it didn't do what it should be doing, so I guess it works. So the challenge for me today, and actually it's also going to be mainly the driver of the whole talk, is to talk more about the why of the web services and the infrastructure services, more than exactly what they are. We're not going to talk about the interfaces. We're not going to talk about how do they really fit together, but more what is there in Amazon's history that actually makes what most people consider to be a bookshop to become an infrastructure provider. Yeah, and so the talk is more about history with some lessons learned among the history. Yeah, and given that I never end up at the end of my slide set, I would like to start with the last slide first. Yeah. When I was still in academia, I wouldn't have dared to do any advertisement. Yeah. But now in industry, I've learned that you can just shamelessly plug what you're here for. One of the reasons I'm here for is that if you really think that this is really interesting, you should come talk to me afterwards, or Don, who sits up front there. We can talk about wonderful careers in technology. Just some facts up front, in case you didn't know them. Also, most of these are not things that you really worry too much about if you're an Amazon customer. But About a third of what Amazon sells actually isn't sold by Amazon themselves, but is sold by third parties on the Amazon platform. Yeah, and even we went into building services specifically, opening up services specifically for people that sell on the platform. There's, for example, a program called Fulfillment by Amazon, where you ship your goods to Amazon warehouses, and we take care of the shipping and the returns and things like that for you. And we make that accessible through web service interfaces again. So you can build your e-commerce operation by using your own techniques, or you can put it in EC2 or whatever you would want to, and then programmatically control your inventory that sits inside the Amazon warehouses. And there's significant growth. You know, we're close to 80 million customers these days. Web service developers are growing at a tremendous speed. I think we added 35,000, almost 40,000 developers in this quarter alone. So this is a world that is still very much growing. And if you look at Amazon, I mean, our history is more that of sort of transformations, yeah, where we used to be a technology consumer largely, consuming a lot of third-party technologies at the beginning. We're now a shop that is almost exclusively homegrown technologies. And there's still a few places inside the Amazon world where we use third-party technologies, but we're actively moving away from them, because kind of the scale at Amazon, you can almost not blame vendors for not being able to deliver technology that actually meets our requirements. And we need to be able to control availability and scale and performance at levels that these tools in general don't give them to you. Also, we used to be just a website and database, and we'll go into that. And in reality now, and that was one of the reasons why I joined Amazon, was that we made the shift from a sort of enterprisey, service-oriented architecture towards a very massively distributed system. Many of the tools that you see in and around Amazon, and whether it's the storage techniques underneath the shopping cart or SimpleDB or S3 or others, all of those are just massively distributed systems. There's no tradition, there's nothing traditional about them. I want you to keep an eye that, you know, this was you when you put up your hand. You're the real retail customer, but there are actually only 1 of 5 customer sets, and each of those customer sets has different functionality that lives inside what we call the Amazon platform. One area that you may not be very much aware of, for example, is the enterprise e-commerce services. Those power very large e-commerce operations such as Target.com, Marks & Spencer, Mothercare. All of those have a very extensive e-commerce operation that is almost exclusively runs on Amazon technology, and where we sell them very high-level services in the order of catalog management, identity management, fulfillment, customer service, things like that. And especially if you look at Marks & Spencer, there's a good example. We also do in-store terminals there, and you do phone sales and things like that. So there is a whole e-commerce operating system that is being sold to very large enterprise customers. This is the early web service that we released, which I always call sort of data integration, because these web services were not as much a service, but they gave you access to data that lived inside the Amazon platform. Whether it is product information or lists or even at one moment a shopping cart, but this is all information that lived inside the Amazon platform and allowed others to build sort of applications on top of that. But where we'll be talking most about today is actually the infrastructure web services, or the history how Amazon came to deliver those. But each of those are different customer groups, and actually we treat them all as customers, and with the same kind of relentless customer focus that we used to for the retail customer, we also try to do that to each of the other customer sets. Which of you actually bought on this website? Darn, actually, I did. This is 1985, and ironically, if I ask my daughters, who are now 19 and 22, they cannot remember a world in which Amazon did not exist. Now, for me, this is still kind of like, wow, magic, really. And I still feel that I'm working for something really new, something that we haven't even touched on what it can really be. And when Jeff Bezos started actually Amazon, it wasn't just because he wanted to do something on the web, but because he realized that there were things that you could do in the internet, in e-commerce in the internet, that were very, very different from how you could do them in regular stores. And that you could do it with providing functionality to customers that you couldn't do anywhere else. So and it was mainly focused on books. And the reason for books was that any reasonably sized bookshop here around campus, even the largest one, may have 35,000 titles in stock. Yeah? And the reason why Amazon was really started, because there was the feeling that you could have 1 million books in stock. Wouldn't that be something magical? Something that you couldn't do anywhere else. You couldn't even do it in the catalog business, because you could print a catalog with 1 million books in it, but who would want to ship that? Yeah, and so there were things that you could only do online, that you couldn't do anywhere else. And that was the main driver for getting Amazon.com off the ground. Now, I can talk about a long story about Amazon's history, but in reality, this is kind of the technology history. The markers in between here are 2000, 2001, and I would say this is 2003 more or less, about 4 years ago. So the first years were all, and I think it's quite common, the first common knowing that there was this motto saying get big fast. And in get big fast we were allowed to violate any architectural principle that there was, and we did that. Yeah, which basically meant that there is a moment then in your history where that decision catches up with you. So the first 5, 6 years were really all focused about building this application server that sat at the front end that would talk to one or more databases in the back end. And each year the scaling was all about how to scale the database, how to cut off tables, how to introduce new databases, how to replicate them, how to suddenly go from being in 1 country to being in 4 countries, what kind of impact that all had on the back end. And all of that was just an application server communicating with databases through ODBC connections. Yeah, and so app servers going down, and if you know anything about how ODBC connections work, it is a very, how shall I say, it is very solid technology, as long as nothing breaks. And in this world, a lot of things break. The app server actually, all of you know that app server. If you've ever looked at the Amazon URLs, for a very long time there was a word in there that says Obidos, which is a small village on the Amazon. That was the name of the app server. And that was the reason also why that showed up in the URLs. Now you'll see that word no longer exists, and if it is, then it's to do some sort of redirection. We hit a point somewhere in 2000, 2001, where this app server couldn't be built anymore. So the architectural principles kind of caught up with it. What this app server, you could start it with a few extra command line arguments and you would get the customer service app. Or some other command line argument and you would get the piece of software that took care of routing of packages to customers. So there was no isolation whatsoever of this software. And there were many different developers all working on one piece of software. So at that moment, the decision had to be made, where are we going technologically? And a number of very smart people at Amazon got together and really looked at the picture, looked at what are the kind of problems that they were experiencing in terms of scaling the backend year after year, and made the decision to go to a service-oriented architecture. And this was way before services were a buzzword, and we will get into detail what was meant by that. But these guys were mainly, they have very good computer science language background, and they took a sort of componentization approach, but in a more distributed way. And we'll get into those details. After we had that service orientation architecture for 2-3 years, Amazon started to grow to the point that from a sort of small distributed system, it became a massive distributed system. And where each of those services needed to scale independently of each of the others, with many dependencies between services, with specific storage requirements within each of those servers. And we went to becoming much more professional, let's call it like that, in dealing with failures. Yeah, for example, at Amazon, we've made the point that you should be able to survive a complete data center failure without the customer being impacted in terms of performance. Yeah, so that's a pretty strong requirement. It has a lot of impact in how you build your software. And we also consider all components in the system, from the lowest level component in terms of hardware to sort of the kind of middleware components, databases, things like that, to be completely unreliable. And if you take that as a starting point, then you have to build software on top of that to overcome all these issues. And that's something that we have perfected in the last 3-4 years, to the point that we feel really good about the things that we do there, and we'll go into details. Yeah, so back to this point in 2000, 2001, where we had this application server, and they were talking to databases. So what we did is a deep analysis of each of the pieces of business logic that sat in the app server, looking at what were the kind of pieces of data that this business logic operated on, and then bring those two things together. So where you end up with is a piece of data. There could be one or more tables in a database, as we started off with databases here, with all the business logic that operated on that specific data sitting next to it. And the only way that you could communicate with this data or with the business logic that sat around it was through hard APIs. So suddenly, no direct database access allowed anymore. That also gave the developers of these services suddenly the power to make changes to their data models without having to actually run a sort of consensus or agreement among all their customers before they could actually make changes. And so this is really, as I see it, a solid, object-oriented, componentized approach. And what Amazon did at the same time was actually move the organization to the same model. Our development organization follows this model, where we had a larger group of different people working on the front end and some operational DBAs that kept the databases alive in the back end. Now we have gone to a model where each service has a small team associated with it of developers that are also responsible for operating the service. There's no separate operations department. The one single team is responsible for this piece of software. If something goes wrong, your beeper will go off at 4 a.m. in the morning, but then there is no greater incentive to actually fix your bugs than having this thing go off at 4 a.m. in the morning. Now, not everybody enjoys that, but you have to live with the consequences of the things that you build. Yeah, and one of the things that we really try to do well at Amazon is, it's this sort of the motto of the best place for builders to build. Yeah, we are a very strong organization focused on building and taking responsibility for the things that you build. Most of these services have a customer-facing component. Yeah, so that way you're also always in the loop with your customers, and you quickly start understanding how you could improve the quality for customers by just optimizing your small local piece. So this is then where you add up with sort of the logical piece. Many different services that form a platform on which all those different sort of customer segments sit on top of. Now this is a picture of one of the tools that we have. The tool is called Maya, and that tracks dependencies of web pages. So this is one of the detail pages, and each dot is a service that is being accessed from that web page. So if you hit the Amazon Gateway page, it goes out to between 250 and 300 different services to actually build that page for you. Now, it can go quite, and it feels extreme, and it is extreme, but it allows us great agility in introducing new services and in actually scaling each of those services in and out. You know, that one little line on the detail page that says sales rank is a separate service. So much of this is product related, and some of them are customer facing services. Now, while we've been running that architecture for a while, we started to realize, or we start to see that there's actually two sort of classes in these services. What I call foundation services are those services that hold the sort of larger, major key data sets. For example, products or items as we call them, customers, offers, items, you know, I wouldn't call necessarily orders to be one of those large data sets. Why do I call them foundation? Because often what you'll see is the key that is associated, the primary key that is associated with entries in these services is often used in calls to these other aggregation services. For example, you may talk to the review service and say, give me all customer reviews for this product, or give me all customer reviews that this customer has written. And you can do all sorts of operations and sorts and selections on those, or have sort of algorithms run within the review service to manipulate the reviews. So two main class of services, the big foundational ones, and sort of aggregation services that work on top of those foundation services. And we will get later into why this is actually important. Now, so all of that was a magic service-oriented architecture, and one of the places where you must have heard the word services more is in software as a service. Yeah, this is a marketing slide I stole from somewhere, and this all explains the wonderful world of software as a service. Yeah, where in the past you had to develop software. Yeah, you developed it, you test it in a cycle, then you go through this release process, you basically burn CDs, you send it to your customers, they install it, they run it on their desktop, and there turns out to be a bug, which for you means you release the next one, send out new CDs, or make new downloads available over the internet, and actually it's a bothersome process. Yeah, lots of resources, but there are lots of software companies out there, so this process has been pretty much refined. This is what software developers are really good at. They know exactly how to deal with this process. Now, the new world looks much better. Yeah, the new world looks the same, develop and test, and then there is this operate thing there. Yeah, then suddenly your software is available, you can access it on the web, and whether these are spreadsheets or whether this is actually Photoshop as a service or whatever you would want to have there, it is great, because now if you find a bug, the only thing you have to do is fix it, release new software to your website, and you really have the principle, and that's sort of the principle we also have really in Amazon, like one bug, one fix, and the whole thing is solved. Yeah, so this is magic. Why wouldn't everybody want to go there? Yeah, there is a sort of elephant in the room. Yeah. You can find the elephant, that's fine, but there is a major elephant, and we've been running these services now for a number of years. Yeah, so we know all about this new process of software as a service. And the real trick is that between that test and operate, there is a sort of a big box missing. Yeah? That big box is something that you as a software development company has no expertise in whatsoever. Yeah? If you're Adobe, and I can say Adobe because they work very hard, they try to be very hard, a software as a service company, and they're also very much aware of the kind of hurdles that they have to take before they are there. Yeah, if you're Adobe and you want to put this online, now you have all these developers that are really, really good in building graphical processors, rendering algorithms, and things like that. But, you know, have them configure load balancers and, you know, manage bandwidth and actually order hardware and predict how much hardware you need. All of these kind of things, these software developers have no clue. And even if they would know how to do it, this is a very time-consuming kind of operation. And you know what? In terms of Amazon's picture, this is where we kind of unexpectedly went wrong with that services model. Yeah, because if we started looking at all those different teams that were building these services, if you looked at what they were doing, about 70% of their time they were not working on their servers. They were doing other things. Yeah, and if you know, if a very large infrastructure such as Amazon, they were configuring load balancers. They were, you know, trying to make sure that for the next month when they expected more traffic, that the resources would be there to make sure that those traffic could be handled. So more than 70% of actually the resources in that team were spent on other things than working on the business logic for that service, what they should be doing. And so, yeah, so just a few examples of things that you have to deal with if you're in this real resources world. Yeah, this is an AT&T data center out in Florida, and for some reason we tend to build data centers where there are also trailer parks, and trailer parks attract tornadoes. If you had actually stored your data in this data center and you didn't have a disaster recovery scenario, then your data is no longer in that center. Yeah, it's gone. This is where it is. It's I have to remember that one. Actually, when you make this joke for a European audience, they'll look at you and say, huh? What are you? 365 Main, downtown San Francisco, and this is probably one of the highest end data centers around here in the valley. Yeah, there's nothing wrong with these guys. They continuously work on all sorts of disaster avoidance and recovery mechanisms. They have 8 generators that kick in the moment that they lose power. They test these diesel generators every week or every 2 weeks. And of course, about 2 months ago, and ironically the lights are still on in this picture, they lost power. But that's no problem. They fire up the diesel generators, all 8 of them, 6 of them fail. What do? You know, so there was no Web 2.0 at that moment anymore. Yeah, for a number of hours that day until they could recover from the outage. A lot of the hot properties in the current internet were just gone. And actually, I don't think there's anything that can be blamed on that particular data center. I mean, you do all the things that you do, and you do them really well, and then you get hit with Murphy, and that's it. It's over. Game's over.
Any reason for the 6 to fail?
Yeah, I think if you actually go to their website, there's a description of a particular component that happened to.
They had a common mode failure.
That's always, by the way, something that you'll see coming back in lots of these stories. We've had many situations where a particular load balancer would fail. But that's not a problem because we have them in pairs. and then you switched over all the traffic to the other load balancer, which exhibits exactly the same bug. And so there's lots of these. You try to be efficient, but so you have to abstract yourself away from all these failures. And you have to take into account, and we'll get there, that all of these failures happen all the time. They just happen. And so you have to build your software to actually be independent of this. Yeah, after this occurrence, you'll see that the east side of the bay, those data centers there, suddenly are getting a lot of new business. Yeah, because suddenly all of these smaller companies start realizing that, oh wait, we need to start spreading stuff. And of course, after this, we saw a significant uptake in some of our business also. The Google guys, together with, and this was at FAST, the File System and Storage Technology Conference, was it last year? Not this year, yeah, last year in 2007. CMU and Google, separately from themselves, from each other, released studies about the failure rates of disks. And more or less it comes down to you'll lose between 8 and 10% of your disks per year in the first 3 years. Yeah, and it's almost during those first 3 years, it's independent of age. It's not like that disks in year 3 fail more than disks in year 1. Actually, there is a significant amount of infant mortality in disks. So what does this mean? This means that if you have a moderately small data center, let's say 10,000 nodes, yeah, and in each of those nodes you have 4 disks, that's 40,000 disks. 10% of those will fail per year. You've got 1 or 2 engineers running around all day doing nothing else but replacing disks. Yeah, and if you think that you could solve this by introducing RAID 5, then you're right in that the logical part of that still exists. That means that one of these disks fail, you can use RAID 5 to access the data that's on the other 2 disks, only that unless you have a very, very high-end RAID 5 controller, the performance suddenly has gone down the drain. Yeah, so you can still access the data, you can actually only access it at something like 10% of the original performance. So it's great for having some sort of a disaster management scenario, but you can't move this problem away. Yeah, unless you put a lot of money on the table, and you know what, maybe you should have gone to a slightly different model there anyway. So this is a scenario where many smaller services and many smaller companies get to deal with, what if I become popular? Yeah, do I ask my VCs for, another 2 million of investment up front just in case I actually hit the jackpot? And there's all these things that have to know how to deal with. I thought that BGP was a done deal. That's an algorithm and a routing scenario that has been around for 30, 40 years now. Why can't that darn thing just be stable? There's only one vendor out there, is there? Well, maybe 2, but after that, and the IETF has been around for a very long time. You should expect that one, nothing should go wrong. Yeah? The truth is different. Yeah? And those are realities that if you want to build your own company or your own service or deal with your own infrastructure, that you have to deal with. It's not about building software, it's about managing infrastructure. And it's very, very complex. There is a lot of expertise necessary actually to get that done. This is the traffic from between Target and Walmart.com, and I'm not put it up just to show you that these guys have about equal traffic. I could also have put Amazon.com up here, but then you can't see this graph anymore. But what I did put it up for actually was to show the peaks during the holiday season. Yeah, and the peaks are about, 2x, 3x of the normal traffic. So what do? Do you send customers away during holiday season? No, you can't do that. You can't have them wait outside in a queue outside your door either, because there's no concept like that. So what do? You just buy servers such that you can handle the maximum capacity of customers that could be coming to your store. And what do you do with those servers the rest of the year? Look at it, the drop is spectacular, bang, 2x down. That means 2x of your servers are sitting around doing nothing for the whole year. And this is even for respectably large e-commerce operations. And even for smaller ones, I really like the guys at 37 Signals. First of all, they build a great product. Check it out, but more importantly, they wrote a book. They wrote a book about, so these are also the guys that do Ruby on Rails and things like that, the inventors, the original developers of Ruby on Rails and things like that. They wrote a book about how they started their company. And the book's called Getting Real. And actually at startup school, here at Stanford last Saturday, DHH, the guy that does most of the Ruby on Rails work, gave actually a presentation there on how important it is to make money if you're a startup company. Something that doesn't everybody understand. Some people think that it's the deal of the importance of a startup company is actually to acquire a VC or to get bought. But these guys, they really have it nailed down to being customer-centric and actually getting paid by your customers. They wrote a book. It's a great book. Actually, you can download it for free off their website. There's a chapter in there that is about priorities, and that talks about scale. And so there they say, and first I had a bit of a beef with them because they said, don't scale. Don't even think about it. It is not important. If you're building your business, scale is not important. And I sit down with them and think, of course it is important. Imagine you become popular. Yeah? They say, no, it's not that. We don't think scale by itself is important, but it's so hard that you can easily, in your first year, get completely lost with thinking about how to scale this business instead of actually thinking about what should I be building such that my customers will actually visit my site or use my application. And so you'll be spending, 7 of your 10 engineers on the scaling side of things instead of the building application side of things. And I think they're right. They have nailed it down really that you should be spending your effort on building a better application instead of figuring out, doing all sorts of research to figure out how to make it scalable. Now remember, these are by now 1,000 services. Yeah, and all of those teams were spending, as we said, about 70% of their time on infrastructure work. So this was the driver for Amazon to start looking at what is it actually that everybody's doing and why can't we just abstract that away from them. And I believe that is nothing more than just a very traditional enterprise architecture approach. Yeah, if you look at other companies that have gone through similar growth. Yesterday in this seminar, I brought up the example of ING Direct. Yeah, ING Direct is a bank that is internet-only bank that is growing tremendously fast in all sorts of different countries. And what they're doing is they take their complete stack and replicate that stack for each country. No shared services whatsoever. There's only a few cases where they have to make some modifications to the software in general to deal with internationalization, but in general they just take the whole stack and run it on a separate set of machines, and that's that other country. It may even run in the same data center. But these guys already know that this is only an approach that they can take for a number of years. Maybe 1 or 2 years, just to take them for this tremendous growth. And then they'll have to start looking at it. What are the shared services that are actually in this picture? And then there will be a platform. Those shared services will fall into the platform because that is the cost-effective thing to do. And so what we went through with Amazon is actually pretty much similar to some sort of, shared services consolidation phase. There is a great book by Peter Weil from the MIT Sloan School of Business. It has enterprise architecture in the title. I forget what the real complete name is, but go on Amazon and you can find it. Peter Weil, enterprise architecture. And And he talks about, how do you want to execute as a business and what kind of enterprise architecture belongs with that. And it's a great read. It's a great practical read also. So this move to infrastructure services, initially we called them Webscale Computing, was purely driven by cost consolidation needs. Yeah? Because we wanted really that our developers were focusing on the right things in the application instead of that they would be focusing on infrastructure. And so there's a few things there. We try to virtualize almost all of the infrastructure pieces that we have. And then to the developer, it needs to seem as if there suddenly is infinite capacity. And we'll get to why a number of these things are important a bit further in the talk. So there are now publicly known to be 5 of these services. And of course there's a few more that we need to keep the internal picture running. Anyone that has any good idea about what operating system services are can figure out what are the other pieces that you would need. But Amazon S3 provides key value storage. Amazon SimpleDB provides multi-attribute storage, say single table storage, on which you can do queries and indexing. SQS is a queuing service, which is mainly used for, let's say, workflow applications and to drive workflow scenarios. And EC2 is our compute environment, where basically you give it a complete virtual machine with all software in there that you want, and you can ask for adding 1 or 2 or 10 or 100 to the infrastructure that you actually have. FPS is our public payment processor, which is the first one actually that's been built with sort of the new economy in mind, where you can have multi-party transactions. For example, a scenario where a certain amount of royalty would go to one party, then there is a provider of the service locally that gets some money from it, and there's a consumer and a provider in a different end. So 3 or 4 party transactions are all the kind of things that this service can handle. These 4 are actually the ones that you'll hear talked about most if you talk about cloud computing. So internally, for our service, for our developers, it looks as if there are an unlimited number of compute units available. You don't have to worry about acquiring and releasing resources. You can always get access to them. And we'll get to it why that is so important. Now this is the standard marketing slide. Most importantly, it is that those infrastructure services are available through a programmatic interface. It's not that you have to go to some website or something like that and fill out a form and do things. No. You can integrate these services into your own load balancing techniques, into your own resource management techniques. That was the whole goal. It's actually 100% developer oriented. But also in a manner that they're open. And which is really the goal of these services, such that you can mix and match different services as you need them. Or if you would want to move to different services, that you can with relative little overhead. So the idea is that the whole collection of services does make sense, but if you would want to decide to start using other services, you can. So then you get up in the beautiful picture that is, this is how you only need to focus on your business and the rest lives outside in the cloud. For us, this started about 4 years ago. And so for the first 2 years, we've been building those services, using them internally, and figuring out that actually developers increase productivity tremendously. Which made us start thinking like, whoa, maybe other people would like to use this also. And that was the sort of a driver for one by one starting releasing these services to the outside world to see what the reaction of the public would be. And well, by now we know how popular it is. And I've got some slide in the end about growth.
By the way, what did that fork?
Q1 results. Hey. And I'm not going to ask. The fork. That's the devil, you know it is. Well, that one was actually all the whatever you have to work away when you're in that environment. Yeah. Some lessons learned. Yeah. If you look at that whole architecture, what are the really important things for us? And these are what I consider 4 non-functional properties that are actually driving a lot of the things that we do in this environment. Yeah. So scalability being number 1. And for that, I actually want to give you a glimpse of the Amazon business model, which is relatively simple. And I'll explain you why I want you to take a look at that. So like any other company, we're interested in growth. Yeah? We believe that there are 2 key drivers in Amazon's business that drive, that are important. Selection, which is the number of items that is in our catalog, and low prices. Now, I know this sounds corny, but low prices is kind of important. Yeah? 10 years from now, low prices still will be important. Yeah, this won't change over time. It's not like 10 years from now people think, who cares about low prices? No, it's actually an extremely important driver. And we'll get to it, how you can feed that one. So both of them drive the customer experience. It drives traffic to the site. More customers come to the site. If there's much more traffic coming towards the Amazon site, which will bring more sellers onto the site, because if there are 80 million people visiting that site, I want my product on there, which magically drives selection. Yeah? So you get this flywheel going by this mechanism. And if you execute this flywheel well, and this growth model quite well, you're able to reduce cost tremendously. Yeah? So you get a lower cost structure, and at Amazon, we've immediately made the decision that a lower cost structure should result in lower prices. So now you have this flywheel that feeds selection. Yeah? Because more sellers come onto the site, your selection grows, and because of that, you can get prices down. So both of them fuel the growth of the company. Now, why am I telling you this? Because remember, we were talking about technology here. This is kind of the result of that model. Yeah? You need to be incrementally scalable if you want to be the technology underneath this particular growth pattern. Yeah? You need to go from a model where infrastructure is a capital expense to be made up front before your business starts. You have to move to a model where it almost becomes a variable cost. Yeah, where as you grow your company, as you add more items to your catalog, as more customers come onto the site, as you get more requests, yeah, that you can handle that almost seamlessly by just adding one node at a time. And so I have this longer definition of scalability, but this is one point. Most importantly, the elastic part of scale, of incremental scale, is very, very important. Namely, incremental scalability doesn't only mean scaling up by one node at a time, it also means scaling down. Because it's very, very important that you'll be able to release capacity if you don't need it. If you've built your software such that you can only scale it up, then there's this sort of self-inflating balloon. No, it is important that software is built also to be able to scale down. And that could be at yearly cycles, it could be at daily cycles, it could also even be at hourly cycles. But if you have this mechanism of getting and releasing capacity pretty fast, then this scaling down becomes really, really important. Let me see, one of the other things I would pick up on here is actually heterogeneity. If you've built your service and your software such that you assume that your infrastructure will be homogeneous, that each node will have the same capacity, the same memory, the same clock bus speed, the same CPU speed, you're out of luck, because that's not reality. Reality is that data centers are continuously filled with new servers, and that the next server that comes in probably will have, double the clock speed of the ones that were there before. Well, no longer double, but they may have doubled the number of cores, maybe, from the previous ones. So if you have built software that assumes this homogeneous environment, you'll be wasting a lot of cycles. Yeah. So it is very important to be able to adapt to what is the capacity of this new node that I have added, and make sure that it actually handles the appropriate portion of the traffic or of the requests that it should be handling based on its capacity. And of course, all these things you need to do without humans in the loop, because that gives you a smooth operation. Also because in general, if you have humans in the loop, things tend to fail more than if they're not in the loop. Yeah? Availability is where scalability probably is more a business property. Availability, without any doubt, is a customer-facing property. Yeah? A lot of the Amazon trust is in that this thing is always there. If the Amazon site is not available, even if it's just for a few minutes, customer trust erodes. Because the whole experience is that Amazon is always there, and always with a certain SLA and a certain experience during your session. Yeah? Now, the problem for us then is that everything fails continuously. Yeah? If you've built an algorithm that says somewhere in the assumptions, and the system will be stable for a sufficiently long amount of time, yeah? That one will not work. Yeah? And for example, there's two other ones. If you make the assumption that failures are not correlated, that things fail independently, yeah? Believe me, everything fails in every possible relation possible. Yeah? Whole racks will fail. Areas of data centers will fail. Routers will be taken out in which it just looks like whole areas have failed. And as we saw in an earlier picture, whole data centers fail. And they do fail. And you should consider that to be a special event. They don't fail every week, but they do fail. And actually at Amazon we run what we call game days, in where we take data centers out. Because if you have these things written down on paper, how all of this works when a data center gets lost, yeah, believe me, yeah, that's not how it works in reality. You have to test these things because otherwise you'll be surprised. And by now that has saved our bacon a number of times. Because when we did run into real situations where we would lose a data center, we could switch over pretty much automatically. So failures are highly correlated. And systems do not fail by stopping. Anyone who has thought up about the fail-stop model, services, systems fail by spewing out large amounts of garbage. Yeah? And not even real garbage. They spit out garbage in a way that it looks real. And that you have a very, very hard time figuring out what is real and what is not. Yeah? But everything fails. Everything fails. From CPUs to memory chips to Linux sitting on top of that. A memory chip fails. Linux will notice it. It will reboot. Yeah? And then it will just start again. And then you wait for 20 seconds until it hits that memory chip again. Yeah? And then it will. And great thing is, it won't log why it actually did the reboot. Yeah? So if you look at all the failure statistics throughout Amazon, there is this reboot spikes that you sometimes see. And it is not because things are suddenly breaking a lot more. It's just because some of your software can't deal very well with these particular failures. Yeah? So disks fail, routers fails, rack fails. Engineers walk around a data center, stumble over electricity cables that go into whole racks. Rack areas fail. Everything. Every possible things fail. And then we haven't even talked about software. Yeah? It's not like software is that terribly much more reliable than that the hardware side is. So in this whole world of continuous failure, you need to be able to maintain the availability as high as possible. And you know what? You're shooting for 100% availability. Okay, you don't achieve it, but that's something else. It's not because we don't want to. Yeah? So 100% availability is always the target. And I think if you hit 4, maybe 5 nines, 5 nines would be great. That would be an exceptional achievement for anyone, I think. But 4 nines is already pretty good. And one thing associated with that is that we have this very large environment. Yeah? And one of the reasons for some of the traditional software development is that the mechanisms in which software are being deployed is very, and built, it's all based on that this whole world is deterministic. Well, believe me, real life is not deterministic. There are not 4 states or 4 inputs and 6 outputs and a state machine in the middle. It's not. There's a lot of unexpectancy happening. On one hand, because of the failures, but on the other hand, there's all sorts of perturbations in the network, especially if you add all sorts of garbage failure modes to it also. So it is important to come to an organizational structure, software organizational structure, at scale, that in a probabilistic manner can provide this service. At the moment that you consider that this service really needs to be, this world needs to function as a binary, it either is 0 or it is 1, yeah, you'll be working very hard to get that 1, but almost never achieve it. If you relax that property from the get-go and say, well, we'll just do our best as much as possible. Go shooting for 5 or 6 nines is a lot less work than shooting for 100%. And so for that you have to let go of some of the control. You have to assume that this is a world where you can launch in new services without that you have to go through a complete review end to end of what the impact on the overall system is. But you need to put controls in place, some controls in place to manage SLAs, to manage monitoring, to manage access control. But this must be an environment where agility can really work. You can throw in a new service there and it should just work. There's some infrastructure necessary for that. But it is not like if you want to launch a new service, you have to go to the committee that manages the data centers or that manages the system to be able to launch your service. You can just go ahead. Performance is the other part there. 3 nines comes back here. So if you talk about the performance to your customers, let's say average performance is 200 milliseconds of whatever it is, 200 milliseconds. What does that mean? Yeah? It probably means that 50% of your customers are getting a worse experience. That's the only thing it really means. Yeah? It says something about the average, but average don't really matter because how bad is this overall experience that your customers are getting? So at Amazon we've taken the approach that we measure all SLAs and all performance at 3 nines. And we also do all the engineering against that particular target. And we know that if we hit 3 nines and really keep that 3 nines under tight control in terms of performance, then you have found most of the experience of your customers. And you can really improve the tail by making that 3 nines performance better. This is very important because it drives a lot of our SLA thinking, for example. Yeah, in traditional old world, SLAs were sort of a one-way street where I would go to a service and the service would give me its SLA. The reality, the real world, if you want to do this well, and if you want to have these very large-scale systems, SLAs need to be two-way streets. Yeah, a client comes to a service saying, this is the graph, or this is the distribution of requests that I'm going to give you, and the service looks at that and will give you an SLA back. And actually all of those SLAs mean nothing until the whole system gets under overload. Because before that, if you can handle all of those requests, even if I send you more requests, it's fine. Yeah? If you can handle that, that's fine. But at the moment that you hit under overload, as a service, you have to start deciding, who am I going to serve? Who should get priority? Yeah, and by then you start looking at the promise that has been given by different clients to you, And based on that, you're going to do the scheduling of requests. Now, cost efficiency, we already talked a little bit about it. These are some of the drivers behind it. You have to be able to acquire and release resources whenever you want to. Remember, releasing resources is extremely important. You only pay for what you use. That's a model we use internally as well as externally, of course. Yeah, and so again, this is using others' core competency. We don't want to hire all sorts of new engineers and have them to become infrastructure specialists. Yeah? We want to hire folks that know all about rendering, or that know all about internationalization, or that know about accessibility and things like that, and have them focus on those particular topics. Yeah? Now, if you look at all of this, all of those 4 different properties, all of them, almost, the major dominant player in that is the way that you manage state. If you look again at this particular picture, what was obvious in this picture is that almost every service maintains some amount of state. And that whether you talk about the availability, or whether you talk about the performance, or whether you talk about any of these other properties, all of them are kind of driven by the way that that service was maintaining its state. So when we started thinking about how to build infrastructure services for this world, the first thing we did was a very deep analysis of how state was being managed and what were really the most important pieces. Now, traditionally, relational databases are the answer to everything. Yeah? Now, and it is mainly because often, if you look at a bigger service or a group of services together that was using one storage technique, somewhere in their requirements would be the requirement to do an ad hoc query. And the only way that you could do an ad hoc query was by having a relational database engine. In reality, actually, when we went through, after the analysis, it turned out that the majority, but way more than the majority, of data access within Amazon is primary key driven. Yeah, and there's a smaller section of that has, the majority of those are also high read volumes. So I mentioned this service that does, holds a large part of the catalog, high volume reads. Updates will not come through the same path as that the reads come in. They come in through a slower backend process. Yeah, it is not that many of these are primary key only. It is just the majority of it, and the high performance path is primary key. There often is a secondary key, but you can have that go through a slow path where sort of an index engine gives you, you go there with the secondary key, it gives you the primary key back, and then you use the primary key interface to actually get that information. The majority of these services could deal with some form of eventual consistency. And we use a specific version of that we like to call user-perceived consistency or session-oriented consistency, where you have a tight management over the window of inconsistency, and you assume that no new requests are going to be made within that window. There's a very, very, very small percentage that actually requires strongly consistent update interfaces. Yeah, and then there's the other section is basically query-based interface, and again the majority within that is relationless. There's only one table. It's in general a bag of attributes, and you just need to be able to search through that. And then somewhere in the end there is some relational work that is required in some of those services, and again a very small percentage that requires strong consistency there. So for us, that made us end up with two services. Yeah, the primary key access is driven by Amazon S3. The query-based access, but relationless, is out of SimpleDB. And for everything else, yeah, we have this storage technology that maps onto Amazon EC2, which you can then use to run databases or other variations of your storage technique. So the persistent storage, we'll get back to that. I don't know how much time I actually have. 10 minutes. 10 minutes, okay. last week we released new numbers about Amazon S3. So these are only the public objects stored in S3. This is not the internal Amazon ones. What you see here is that when just after we launched, we had about 800 million objects in it. When we counted again last month, there were 18 billion in them. And as you can see, yeah, the time spaces between these bars are not, how to say, uniform. So it makes it hard for you guys to actually imagine the line and extrapolate where the line is going. Do they have something like this? So another thing that we launched recently, I assume that you guys know all about how S3 and EC2 and the basic premises around those services. Another thing that we recently launched is called availability zones, which allows you to create resources in zones that are likely to fail independently. And remember, I just said that all these things fail within every possible correlation, but there is some physical isolation between the different availability zones that you can have with high probability. Those zones will fail independently. So the world is divided into regions, and each region is divided into availability zones. The guarantee is that within each region, those resources in availability zones have relative low latency communication techniques. Another thing we launched was the we call elastic IP addresses, which allows customers to allocate a block of IP addresses and map those dynamically onto their instances. And we make sure that data gets routed in the right direction. So if you lose an availability zone, or if you decide to move this IP address to a completely different availability zone, we make sure that the routing paths associated with that move that way also. The most recent storage technology that we've launched and where we've been talking about is called persistent storage for Amazon EC2. This allows you within one availability zone to create volumes. And volumes are basically just block storage devices, although that's how they appear to you. Yeah, you can create a volume. I think sizes are between 1 gig and 1 terabyte. You create that one, and you then mount it, and after that you can do with it what you want to. You can run a high-end database that can talk to a raw disk directly, or you can format it with a file system or whatever you want to do. Important is that you can detach the volume also again, and if nodes fail, they automatically get released, and you can reattach it to other instances. But with that, it also came the ability to do snapshots. So you can, because this volume is only available within this availability zone, you need to have a mechanism in which you can actually transfer data to other availability zones if you would want to do failover to that. So there's a snapshot mechanism that comes with it. You can snapshot these volumes into S3, and S3 is available throughout all availability zones. And you can use that snapshot to create new volumes from. Yeah, so if I created a snapshot, I can point to it and say, give me a new volume based on that snapshot. And you can also use it for doing rollback techniques and recovery-oriented technique and things like that. Yeah, so if you look at a few of those examples, this is, I like this part actually. Yeah. Amazon will be like a bookstore that sells cocaine out of the back door. Being from Amsterdam, I really feel back at home. Yeah. So books will be just a front to selling storage and cloud computing. I didn't make up this myself. It's obvious that to be able to actually sell books and to be able to sell all the other articles that we do at Amazon and to extend the number of categories that we go into and to grow this business, for us, scalability and doing this at scale and maintaining that scale is extremely important. If we wouldn't be experts in that, we wouldn't be able to sell books. Yeah, so the ability to sell books, although there's a lot of secret sauce around recommendations and things like that, the real secret sauce of that business is actually being able to operate at scale. And in that sense, I feel that we can operate any business at scale, as long as it's driven by technology. Yeah, so a few stories, the New York Times. So there's a lot of different customers that we see in the whole space. You know, there's a lot of startups, because that's the guys that have got the most of the attention of using our services. But in reality, a very, very large part of this is used by enterprises. And you see different kinds of enterprises coming on board. And each of them comes on board through sort of a different mechanism. So in this case, what the New York Times wanted to do was take all their articles from 18-something to 1942, for which they had scanned in, and they had TIFFs of them, and they wanted to create PDFs from it. Yeah? So they scoped the project and decided they needed 6 servers to do this, and then they could do it in a month. Yeah? Unfortunately, nowhere within the New York Times were 6 servers that would be free for a month, so they had to buy them. Yeah? But that was kind of, the CEO then kind of gets upset. He says, why do I have to buy 6 servers? Because after this month, this project will be over. There's no more new pages in 1942 being added. Yeah? So after that, this thing would stand empty. So the engineer that actually was responsible for that in that weekend moved 3 terabytes into S3, allocated 100 nodes, and within 24 hours he had done all the conversions of TIFF to PDF. Yeah, $24. That's all. Yeah. Then he realized that he'd made an error in the algorithm, and where the dates were wrong in the PDF. He just did it again for 24 hours. Yeah, another $24, and that's the whole project. Yeah. This is how some of this stuff looks like. This was 1892. They asked for computers. Yeah, and you guys can look at the slide later to actually see what a computer in those days was. This is a disk you can buy from. This is a USB stick that you can buy from SanDisk. Anything you store on it automatically is being backed up into S3. Yeah, with a separate interface that if you ever lose that disk or whatever, you can retrieve it from S3. It is very important to think about separating some of these applications from the storage. You, as a consumer, may want to own the storage where your data gets into. In the case that this company no longer exists in 2 years from now, you may still want access to your data that this company was actually collecting for you. Yeah, so that's an important part of this. And this is a fun story of last week. Animoto is a company that takes a series of images and takes some music, analyzes that music and analyzes your images, and then builds a sort of movie of it where things change really on the beat of the music. It's magic. Yeah, it's great fun. It's useless but fun. No, that's not true. I didn't say that. Yeah, but no, it is really fun. I did it this morning, and you know, I took actually all the slides from today and moved them in there, and just had them see what they would come up to with, and then put some nice techno underneath there, and you would have gotten a lot more dynamic presentation, believe me. But it's really cool. It's absolutely. So what they did something really, really great last week. They added functionality such that you could take photos out of your Facebook account. And if you then would create this movie, it would tell the people that you had tagged in your photos. They would send them a message saying like, and here is this movie for you, which immediately made this service extremely popular among Facebook holders. Yeah? This is their, this is the early beginning of the week. You know, they were running at about 50 instances of EC2. Yeah? This is where they launched the new feature. Yeah? So they go from 50 instances to 3,500. Yeah? And I think currently they're running at somewhere between 4,000 and 5,000, and it's not letting up. Yeah? So they've built themselves a really, really nice architecture. Yeah? They use SQS to push work items into from photographs that need to be copied into S3. Then once that is done, the units of work go into a next queue. that queue is being monitored. If there's too many items in that queue, then more workers are being spawned up. And so they really build a very adaptive environment. And most importantly also, these blips here, they are not failures. These blips here are somewhere between 2 and 4 in the morning, where they actually had processed most of the work that had been done, and they started releasing instances because they no longer needed them. Yeah, and as you can see, that only takes about an hour or two before the next wave in the world comes online and actually drives them to that point. Yeah? And you know, what I said before about users, it's an absolute great app. I urge you to go to it and actually see how they built this small free movie for you. And you know, you really see, they sort of indicate graphically how this work flows from, you know, analyzing the videos and analyzing the music and how all these pieces get set together. It's magic. Yeah. This is another quote from the federal government. Federal Computing Weekly or something like that. Yeah. So this is the Defense Intelligence Systems Agency. They do all system management for all of the armed forces. They had estimated that they needed 30,000 to actually build this prototype of this service. In the end, $5. Yeah, but the main win here, actually maybe from a taxpayer point of view, you really like this, but for them the major win was that a traditional process within the federal world is that once you start developing a prototype, actually up front, you have to request the resources you need at the end. Even before you have built your software, even before you have a clue about what you really, really need, yeah, you have to already order them because it may take 6 months before it actually arrives. Yeah? For them, the major win of using things like Amazon EC2 is that they don't need to put out this work order. And they can wait till the last moment to actually start using these resources. So there's a lot of different scenarios that we see that really work out well for many different enterprises. Yeah, so for you also, it's easy. The only thing you need is a credit card, yeah, and this URL, and you can get going. Thank you. Question?
With the shopping spikes, and so then you release those servers. Now, I benefit as a developer, but Amazon ends up with this huge pool of servers that nobody's using.
So the whole idea around this model is that we go to such a large scale, and such a large probabilistic usage of it, that it will dwarf. Is there a slide after this? Did I mix? Oh, I have a different slide that I could show you, which demonstrates the bandwidth usage of these services over the bandwidth used, for example, by the Amazon.com properties. A year or a year and a half after we've launched the first services, all the bandwidth coming out of S3 overtook all the bandwidth coming out of the Amazon e-commerce properties. And as you can see, that kind of goes on a very, where Amazon traditionally grows, what is it, 30% year over the year, more or less. But this is a very steep climb. So the amount of resources available in the cloud greatly exceeds the resources required by Amazon.com, and definitely the resources we need to come and go. And you should assume that there is enough diversity in the customer set such that you can optimize usage very well.
But not within Amazon properties themselves.
We're just a user of this.
But I'm saying the Amazon properties themselves were subject to spikes because
Absolutely.
It's all retail. So by offering the service outside, you were able to.
Absolutely, yes.
And that saved the
No, yeah.
Okay.
So no, we benefit. The ulterior motive could be seen as that the things that you really are good at is something that you would want to offer to everybody else. But there are some, let's say, side effects that are good for the Amazon business itself also. Yes.
Hi, it's very exciting, by the way, thank you. But my question is if a service that wants to use your service, a company, is hesitant to post their customers' data, which may be sensitive, how do you address the security of certain data?
Sensitive data, there's almost only one way that you can deal with it, that is through end-to-end security. And so if you want to store things in S3 that are sensitive, in whatever manner, you need to encrypt it at your end and decrypt it. There's no other answer to that story. And that has nothing to do with Amazon S3. I think any storage servers, but even local, you would need to do end-to-end encryption to deal with that problem. It's a question we get a lot. There's a lot of international jurisdictions that require you to deal differently with different types of data. For some it will be impossible. For others, the future will be that this will be available in that many jurisdictions that we may be able to overcome some of those issues.
Have you considered using variable pricing for the resources rather than fixed pricing?
No. So, but variable pricing, so in general, no, there's a fixed price for everyone. But we already use tiering in the pricing. Yeah, so the more you use the next tier up, the resources actually become less expensive. But the main goal for us has been that we try to follow a cost following model, meaning that as Amazon, just like in the original business plan picture, if Amazon realizes cost savings, then we immediately translate that into cost savings towards our customers. Today we launched a reduction of the Amazon bandwidth prices for S3 because those were gains that we were able to make ourselves. And so we passed those cost savings on directly to our customers.
You showed some of the use cases of the Amazon EC2, but do you have some of the customer base? I mean, do you have any slide showing the...
Who are using EC2? So I don't have a slide with that, but there's a very broad range. Yeah, and of course the startups are the most vocal ones and the most obvious ones out there. I mean, the Animoto guys are great examples of how they would never have been able to build their business if upfront they would have to buy 5,000 servers just to start off. Yeah, so there's a great story around startups, of course, but a large section of the EC2 users are enterprise users. And at one end, for example, that is the traditional parallel computing world, pharmaceuticals, financial industries, who almost have an unlimited appetite. And then another large bucket in there is, for example, software companies. Q&A and testing are normally parts of the software development process that are kind of frowned upon. They're necessary, but they don't really contribute. Some companies take that attitude. And so these departments always have a lack of resources. And if they would have to test the other operating system, they often have to re-image disks and things like that. In the EC2 world, they're actually capable of having a number of ready-made operating systems. They just fire them up. They don't have to worry about pollution, or they can fire them off with different data sets. And so testing is a lot easier in an EC2 environment. Also there's the category there of companies that want to go to a software as a service model. And they just don't want to deal with all the complexity of managing your hardware and software yourself. One particular good category there is the current middleware vendors. The ones that provide very large, let's say, enterprise service buses or enterprise middleware software where others can build applications against. The good thing about the EC2 model is that you can run legacy software in there without too much trouble. You don't have to rewrite your software to make use of the Amazon cloud. Of course, if you want to use S3, then you would have to start using S3 through the particular interface, but it's a very simple interface. It's just get and put. No, there isn't that much to it. Another section is people that resell our services and that actually build additional software on top of EC2 that really deals with EC2 themselves. Database management, load balancing. There were folks, one of the reasons why we quite early already started talking about persistent storage for EC2 was because we saw a lot of development happening out there by users of EC2 in trying to overcome some of the limitations. There were folks that were building a GFS clone just such that they could do Hadoop on top of it and things like that. And so there are some services that Amazon is better off in providing it in the cloud than our customers. But there's a whole range of other sort of support services that we assume groups in the ecosystem will start building. And we see quite a few good examples already.
Are there any application categories that you would say EC2 is not applicable to, such as the ones that have to do with latency? Would you say people want to run their trading systems that may be event-oriented and latency and throughput may matter, should come to EC2 and consider it?
Actually, I had a good example recently, but I kind of forgot. But let's take the trading example. Often I try to challenge people that come to EC2 and says, and I can't do this. I mean, it's a virtual machine. You can't do I/O in a virtual machine. And I sometimes challenge them to think about the cost versus functionality that you get. One area, for example, is data warehousing. Data warehousing is a traditionally is done on very high-end hardware, very expensive I/O infrastructures, and it in
latency-intensive applications. Data warehousing is not latency-intensive. Take a system that is like somebody wants to write an application that runs the city's traffic lights and automates them, and latency matters to them, or take a plant.
Within the confines of EC2, you get low latency as you would get within any.
What is the SLA for latency? What do you tell your...
At this moment there is no SLAs in that world. And the reason for that is because we have to learn about what is the kind of SLAs that we can provide and what SLAs actually make sense. So we've talked, when we released the availability SLA for S3, we talked a lot before that about what other SLAs would make sense. And of course, a latency SLA is the first one that comes on the table. But in an internet world, what is it that we can provide in terms of latency guarantees? Is it that we can give you guarantees to where the data leaves the servers? Well, it doesn't really make sense, does it? I mean, we could provide that guarantee, but it wouldn't help you as a customer. So in terms of SLAs, we're working very hard and looking at each of the different services and looking at what kind of guarantees, what kind of SLAs can we provide that make sense? And also, what is the kind of cost models that should go with that? Because an SLA is one thing, but if an SLA is something that you can just violate whenever you want to, then it isn't really an SLA. You know, you as a user of the SLAs are almost in an insurance game. Because if we fail to meet the SLA, then you must be able to go to an insurance company and claim that, almost. I mean, that's the kind of the model around SLAs. SLAs mean, there's a financial model behind it. Instead of that, it's only technology driven. So no, we're not there yet with those SLAs, but believe me, 2-3 years from now, this world in general will look very different.
I think we're running out of time. I'm certain that we go down and address individual questions around the podium. And thank you very much.
For information on other online Stanford seminars and courses, please visit study.stanford.edu.
The preceding program is copyrighted by Stanford University. Please visit us at stanford.edu.